Look there, now we are back to our intermolecular and intramolecular forces. So till now, I think you might have even revised and all your doubts might be cleared based on these forces. So I think in our last lecture, we discussed up to this slide, no? So we have to discuss from induced dipole. So what do you understand by induced dipole? Just by the name itself, you can understand induced. Induced means what? You have created it. You have helped it to become a dipole. The dipole was not present before. So that's why it is a temporary dipole in one particle causes redistribution of electron in nearby particles. So temporary dipole in one particle. For example, let's say I had an O2 molecule and I brought it in contact or in the atmosphere of the H2O. Now, because of this was dipole, right? So, because of the presence of dipole, this non-polar molecule is becoming polar. Because of this interaction from the negative terminal, this will become slightly positive and the electron cloud that was uniform in that oxygen now will be redistributed and you will see that the electron cloud will be more toward the second oxygen this way. Can you understand that? Electron cloud will be like this. Okay, that means more electron cloud will be toward the second oxygen. That means this is getting a negative charge and this one is getting a positive charge. Now, because this molecule was non-polar before, but the polarity has been induced in this because of the polar particles. Now, this is having a temporary dipole. Okay, this is having a temporary dipole. Now, if I take this molecule that is having a temporary dipole, if when it comes in contact with the other particle, it causes redistribution of electron to all the nearby atoms. So that's what we said that temporary dipole in one particle, that is this one, causes redistribution of electron in nearby particles. So if any other particles were around them, all other particles will be getting redistributed again because of this dipole. Getting my point? Because of this induced dipole, the others are also getting induced. Dipole is getting induced in other particles also. So this is called as, these two interactions called as induced dipole and induced dipole interaction. This is dipole and induced dipole interaction, and this one is, you can say, first one that I have drawn the diagram for the first one. This one is dipole and induced dipole. Dipole, induced dipole. I will write dipole, induced dipole interaction. That is first one. Now next one is induced dipole interaction. Okay, this is for the second one, right? So this creates induced dipole. The temporary dipole that was created in the first molecule, this is going to further create the dipole in next molecules also. That is called as induced dipoles. Now you can understand that they are not permanent dipoles, so the forces must be very weak, right? Because they are not complete dipoles. That's why they are weak forces. So weak attraction occurs between these particles. All right, this point you understood? Next point is these attractions are dispersion forces. So these attractions that were created between induced dipole molecules are called as dispersion forces. What they are called? Dispersion forces. So this was all about the induced dipole dispersion force, or also you can say London forces. Next point, examples of weak dipole forces. Substances with a few electrons have weak dispersion forces. That you know, if less electrons are there, less attraction is possible, right? For example, you can see noble gases, they have electrons and they don't have polarity in them. But because of the presence of any other molecule that have some polarity, they can get polarized. Now, next example, H2, F2, CH2. Basically, what happens, you see, if I'm taking the neon, right? Now, if I have this, let's say I have drawn a electron cloud over here, okay? Now, I have one more neon gas, another electron cloud for this one also. Now, this neon is positive charge, like protons are present in the nucleus, so nucleus is positive charge and electrons are negatively charged. Now, this might be having some kind of repulsion, and there is some kind of repulsion. So, this is going to be attracted toward this electron, this nucleus is going to be attracted toward this electron. So there is some kind of force of attraction acting between them because of the nucleus of one molecule and the electrons of other molecule. This type of forces, you can call them dispersion forces. And obviously they are weak because you don't have permanent dipole. Electrons are just shifted. How they are shifted? But now see, here electrons are there, so they will feel repulsion. So electron cloud will shift this way. Getting my point? So this is going to shift in this way. So that will cause a dispersion force. So this force acting between these two molecules will be called as dispersion. That's why we have taken this neutral species. They don't have this dipole in the molecule. In this one, dipole is being cancelled out. So these usually have low boiling point and exist as gases at room temperature. Why? Because the particles that are that force that are holding these two particles, as I have shown you in the diagram previously that I have drawn, are weak, right? Because these are dispersion forces because they are non-dipole molecules. So these are dispersion forces. They are obviously weak. Now, because they are weak, so if you provide little amount of energy, this can be broken easily, right? If something is weak, you can break it easily just by providing small amount of energy. So while you are heating it, very less amount of heat energy is required to dissolve this bond and to make the molecule that is present in the liquid state into convert into gaseous state. So they can be easily boils at a low boiling point. Okay, so if I say this is having a strong, if any two particles I have, I'm saying that any two particles that I have are having a strong force of interaction. If I say this is a strong, so definitely this must be having high boiling point. High boiling point. Why? Because then you need high amount of heat energy that will rise the temperature to break this bond, right? Because the bond is strong. Clear? So see, next slide, larger molecules and dispersion forces. That means larger molecules have more electrons, so your dispersion force is going to be increased. That's why we see as we increase the molar mass of the molecule, boiling point increases in that order. So stronger dispersion forces leads to higher melting or boiling point, right? That's why we see that if I have, see, octane and the candle wax. This is having 8 carbon and 18 hydrogen, but the next one is solid. Why they are solid? Because they have little more little more dispersion force, or you can say little stronger dispersion force than the octane. That's why they are solid and octane is liquid. Because the particles are bonded little much stronger way than the octane. I think you might have studied about the states of matter, in which you understand that while liquid particles are having weak force of attraction and solid particles are having higher force of attraction. So that is because of the dispersion force that exists between the two molecules. So if you have more molecules, larger molecules, this is the larger molecules. Larger molecules have more electron. That's why they have more higher dispersion force. All right. Like dispersion force and molecular size. Yes, as I told you, molecular size becomes larger, your dispersion force will increase. Molecules can pack closer together if you have higher masses, right? Next example is halogen train. You can see fluorine is a gas, chlorine is a gas, bromine liquid, iodine is solid. Why so? Because as we are going downward, what happens? The size of the molecules increases as well as the total number of electron that is present in the iodine is higher than the bromine, chlorine, and fluorine. Like increase in the electron density is higher as we go down, right? Higher. That's why dispersion force is going to be increased downwards. That's why if more dispersion force between the particles, that means the particles are going to be having a more force, a stronger bonding, a stronger intermolecular bonding. That's why they can be solid, right? So as the molecular size increases, dispersion forces increases, raising the melting point and the boiling points, right? Next, we have dipole-dipole interaction. So this occurs between polar molecules. By the name itself, you can understand, see, dipole and dipole. That means you are having two types of dipoles. So positive ends of one dipole attracts the negative end of the other. These attractions occur simultaneously throughout the sample. That means, let's say if I'm taking HCl molecule. So if I have another HCl, okay, this is HCl. That means this is negative, this is positive. This is positive, this is negative. They have dipole by themselves. Like they are not induced. They are dipole molecules. So there is a force that exists between these two. This force is called as dipole. The name of two molecules is given. Both of them must be dipole. Okay, one dipole, another one must also be a dipole molecule. Then the positive end of one attracts the negative end of another. See, positive end of one attracts the negative end of the other. These attractions occur simultaneously throughout the sample. So it will occur all over through the system or sample that you have. Now, effect of dipole-dipole forces. Again, polar molecule experiences dispersion force also as well as the dipole-dipole attraction. Dispersion force is present everywhere. That is because of the nucleus and the electron. So everyone it is there. So this combination produces a stronger intermolecular forces and a higher boiling point. So when you have dipole-dipole interaction, this is little stronger. You can say stronger than dispersion. So if I say order, so hydrogen bonding will be the strongest of these. Then you will have dipole-dipole. Then you will have dispersion or London forces, right? Next, example comparison. So if we have argon. Now you know argon is neutral gas, like they are inert, they are not going to make any bond, they're not going to lose any electron or accept. That's why they are neutral. And so they have only the dispersion forces. Only dispersion force exists between their atoms. Now in the case of HCl, you have dipole-dipole, isn't it? So both have 18 electrons, but HCl is polar and experiences higher dipole-dipole attraction. That's why you see difference in boiling point. The boiling point of argon is minus 186, but the boiling point of hydrogen chloride is minus 83.7. So this is the difference why you have to understand what type of forces are present between the molecules. Next, we have hydrogen bonding that you know very well. Now, they are the special type of dipole-dipole attraction in which you are having a higher electronegative atoms. That means the hydrogen is connected with the higher electronegative atoms that can be nitrogen, oxygen, or fluorine. So by that you can understand if you have higher electronegative electron, that means these higher electronegative atoms are going to attract the electron with a greater power than the attraction was occurred in the dipole-dipole. So that means because of that higher attraction, this is going to be the strongest of all three types of intermolecular bonding. Okay, so why hydrogen bonding occurs? So electron move towards the electronegative atoms. That means if I say HF molecule, okay, so it is thought that if you have a bond, your a shared electron must lie in the center of this bond. But that does not happen. If you have a very high electronegative element, then what happens? They attracts the electron toward themselves. So they are not in the center, but not completely transferred toward fluorine also. They are just little shifted toward the fluorine because of the higher attraction power of the fluorine. What is electronegativity, you know? That is the tendency of atom to attract the shared pairs of electron toward itself. So, because fluorine is having higher electronegativity that you can understand from the periodic table, as you go down, your electronegativity decreases, and as you go across the period, your electronegativity increases. So, fluorine is having higher electronegativity. Because of that, this is going to attract it toward itself, and this is why this is getting a very good polarity. All right. So this leaves the hydrogen atom partially positive and exposed. Now this is exposed to something that carries the electron. It can be attracted toward electron if someone brings to them. Right. So positive hydrogen is then attracted to the lone pairs. So if you have another, if I write, if you have another HF molecule, so HF molecule. Now this fluorine have the lone pairs, right? So this lone pair can be getting attracted towards the hydrogen because this is very like having a partial positive charge. It is a dipole and it is fluorine is having a lone pair, like they have three lone pairs, right? So they are going to be attracted with a very good strength. All right. So that's why they have a very good strength. Now, characteristics of hydrogen bonding are occurs only between the molecules. What kind of molecule? Polar molecules. Polar in that case, you must have a hydrogen and a high electronegative element, that is hydrogen with fluorine, oxygen, or nitrogen. That's all. Stronger than represented using dotted line. So how you are going to represent that a bond exists between these molecules? You should show by a dotted line. Okay. Then stronger than the other dipole-dipole forces, still weaker than the covalent bond. You know that because they are still the attractions. They are not bond. But covalent bond is made by sharing of electron. That's why this is the strongest one. So what will be the order now? Covalent bond, then hydrogen bonding, then you will have dipole-dipole, and then dispersion. All right, so this will be your order. Examples of hydrogen bonding, if you are asked to write that, you will say water, ammonia, hydrogen fluoride, alcohols. Why alcohols? Because in alcohols you have O and H bond. Any R group can be present. R group means alkyl group or alkene group or aryl group. That doesn't matter. But you have OH group with them. Alright? For example, methanol. So you have CH3OH. If I say ethanol, so you have CH2OH. Alright? So these are the examples where you can find the hydrogen bonding. Now, what are the effects of hydrogen bonding? Because you know they are strong enough to hold the molecules together in a compactly packed structure. That's why they leads to higher melting and the boiling point. So these values are higher than expected for molecules of the same size.